I thought we, had maybe, when starting SpaceX, maybe had a 10% chance of reaching orbit, so.
Gravity and distance make launching heavy cargo almost impossible. Earth's atmosphere drags down every rocket. Every launch on Earth costs billions of dollars in fuel. It takes months to prepare a single flight. This limits how much cargo we can send into space. SpaceX looked at this problem differently. They wanted to launch satellites without using any rockets at all. Rockets are expensive and slow. Every Earth launch still limits what we can do in orbit. He had a wild idea that sounded like science fiction. He wanted to build factories on the moon. These factories would make satellites right there on the lunar surface. Then they would use a giant railgun to shoot them into orbit. This railgun is called a mass driver. It is about 6 kilometers long. It pushes things so fast they escape the moon's weak gravity. Think of it like a giant electromagnetic ramp. The escape speed on the moon is only 2.4 kilometers per second. That is roughly 7 times faster than a bullet from a rifle. The moon does not have any air to slow the cargo down. There are no explosions or fuel dumping. You do not have to wait months for a rocket. You just push the cargo and go. At first, the engineers tried the math on paper. Lunar soil has oxygen and metals, but mining that soil is brutal work. Every robot prototype failed at digging or refining. One robot tried to chip rocks for a week. It overheated and broke after only 6 hours. Another robot melted its wiring from the sun. The engineers kept thinking like they were on Earth. Approach killed their early designs. Then they realized the moon is a completely different place. Low gravity means machines can be lighter. Solar power is constant in some regions. Once you have the mass driver, the physics favor speed over brute force. Suddenly, the impossible looked like it could work. The mass driver concept is a technical marvel. It is basically a long electromagnetic track. You put a satellite on the rail. The track sends pulses that move the satellite along the track. These pulses must be timed perfectly. Imagine flicking a marble across a magnetized ramp, only this ramp is much bigger and faster. One misstep and the satellite smashes into the end of the track. It does not reach orbit if the timing is off. Engineers calculated the gaps down to millimeters. They built test segments on Earth first. A 50-meter track worked for tiny things. A 500-meter track pushed 500-kilogram satellites. They reached speeds over 1 kilometer per second. The team celebrated every small success like a championship win, but that was not enough for the long-term goal. They wanted megaton-scale production. That means billions of tons of material processed every year. Nuclear and solar grids on the moon would power the factories. Oxygen and aluminum and titanium come from the lunar soil. One factory could produce 1,200 tons of material every day. That is enough to fill 240 cargo planes daily. Each satellite made on the moon avoids Earth launch costs of $200 million. The scale of this plan is staggering. Musk has a vision for terawatts of computer power in orbit. This would power artificial intelligence beyond anything on Earth. By December 6th, Musk posted about using these factories. He wants to shoot satellites into lunar orbit with mass drivers. By December 18th, he saw a giant lunar base. It would be fully automated. It would be capable of sending satellites deeper into space. These were not just empty posts. They had sketches and rough numbers and timelines. Musk confirmed the market value could hit $100 trillion. They were not just guessing. The satellite designs are modular. Each unit carries computing chips and solar arrays. They carry communication hardware too. The artificial intelligence cores are shielded to survive the launch. They weigh about 2,500 kilograms. That is about the size of a small car. The mass driver handles them like marbles. It shoots multiple units every hour. A full day could send hundreds of units into orbit. An Earth launch would need dozens of rockets to do that. It would take hundreds of engineers and over $1 billion in fuel. The moon method is quieter and faster. It is much cheaper over the long term. These factories must work with almost no humans. Robots are designed to maintain themselves. They carry spare parts in automated piles. If a digger breaks, a new part is printed. Conveyor belts move the lunar soil to refining units. One system pulls out the oxygen. Another gets the aluminum and silicon. Coordination of these robots is very complex. Timing errors can ruin a whole batch of metal. Engineers used artificial intelligence to run the factory. The system learns from mistakes and reacts instantly. It avoids the lag that humans create. Precision matters more than power here. The mass driver pulses must match the satellite weight and heat. One 30-second misfire and millions of dollars are wasted. By the second test on Earth, they reached near perfection. They had 99.8% successful launches. That gave Musk the confidence to approve the moon build. Competition adds another layer to this race. China has aggressive plans for satellites. They launched 1,500 units by 2025. SpaceX countered by showing the moon base could do more. It could output 10,000 units every year. That is over 6 times the competition. Europe is lagging behind with only 300 satellites. Numbers matter on this scoreboard. It shows who controls future computing power. Musk positioned SpaceX far ahead of everyone else. NASA plays a minor role in this specific setup. They run tests, but they lack the industrial scale. Boeing attempted heavy lunar cargo in 2024. Their costs ballooned to $35 billion. The mass driver approach beats that by efficiency alone. Engineers predicted 80% lower costs per unit. Every kilogram of payload costs less than 1/10 of the old way. Timeline tracking shows very rapid progress. By January 2026, the diggers were working. They completed 500 meters of trenches for foundations. Solar arrays reached 200 megawatts. Mass driver rails were 6 kilometers long. Every milestone was validated with photos and data. In March, the first big satellite test fired. It worked perfectly on the first run. Nobody expected perfection so soon. Rockets cost billions and risk failure. Lunar mass drivers reduce both the risk and the cost. Artificial intelligence factories can scale forever. Recognizing this pattern shows why SpaceX dominates. Every competitor repeats the mistakes of the past. They over-engineer for Earth conditions. SpaceX designed specifically for the moon. This simple insight gives them a massive advantage. The technical mastery shows in the software integration. Satellites now coordinate themselves in orbit. They form groups and share the computing loads. If one unit fails, the others compensate. This allows for adaptive routing and error correction. The system learns and improves every day. This turns impossible ideas into real outcomes. It is a new kind of technical victory. Each satellite deployed multiplies the computing power in space. This affects weather prediction and research on Earth. One satellite can do trillions of operations every second. With thousands in orbit, the Earth grid seems tiny. Musk wants technological dominance. He approved automation and mass driver scaling. One engineer argued for more Earth testing first. That would have delayed the project by years. Musk insisted on lunar trials instead. That decision led directly to the breakthrough speed. The risk was high, but the reward was even higher. System analysis shows how many innovations work together. Mass driver mechanics and lunar mining tech converge. Together they create a cost-effective path to deep space. The first lunar satellite fired correctly on March 17th. Telemetry confirmed the orbit was perfect. The system booted up and started moving data. The engineers cheered because the success rate was 100. The metrics showed zero fuel use and near-instant deployment. Validation of the system was complete. Future projections are staggering to think about. Production could reach megaton levels annually. Hundreds of thousands of satellites could be in orbit by 2030. Deep space missions could begin in that same decade. SpaceX is positioning itself for the whole solar system. Competitors struggle to match this scale. Financial analysis reinforces the impact of these wins. Each satellite saves $200 million. The upfront investment is high, but it pays off fast. Shareholders have a lot of confidence in this path. SpaceX has terawatt-level computing that eclipses China and Europe. Efficiency and speed create a gap that is unlikely to close. By December 2026, the operations were continuous. Robots mine and refine and assemble all day. Failures have dropped below 0.2%. Railgun timing continues to improve. Factories scale up with modular additions. Every new part increases output without slowing down. The technical mechanics highlight the precision. Electromagnets pulse every millisecond. Rail allows for extreme speed. Lunar gravity allows for lower energy use. The artificial intelligence predicts mass shifts during the launch. One miscalculation could destroy the cargo. Precision here equals efficiency and faster deployment. The pace of the timeline is accelerating. Results build momentum and attract more investment. Each satellite helps the next one launch better. The system is self-improving. It adapts to moon dust and track wear. This closed-loop learning is revolutionary. By late 2027, over 1,000 satellites will be working. The constellations manage themselves. Production scales with lunar expansion. SpaceX ensures it controls the orbital computing power. This edge is impossible to overstate. Lunar factories unlock deep space operations. Mars and asteroid mining become feasible. SpaceX sets the standard for the industry. Technical mastery and strategic foresight make it real. The achievement is clear to see. Costs are dropping and computing is scaling. The next frontier is deep space, and SpaceX leads the way. Elon Musk has been talking about things from a movie. He says lunar factories and mass drivers add huge computing power. You have felt that awe when imagining something big. Most people think satellites are tiny things. This plan changes that completely. It is like building cities of artificial intelligence in orbit. One satellite produces 100 kilowatts of energy. We are talking about over 100 terawatts annually. That is thousands of times more than Earth farms can do. Starship alone could only deliver 500 gigawatts, but moon factories push the limit beyond imagination. Manufacturing on the moon is not just about more units. It is about building without raw materials from Earth. Mining the moon and making solar panels there cuts costs. SpaceX does not have to carry every pound from Earth. Instead, they build billions of tons in orbit. Nobody talks about this specific part. It is the combination of mining and launch that works. By the time one unit reaches orbit, another is ready. The engineering is incredible. They use closed-loop systems that are self-sustaining. Each production line runs with almost zero maintenance. You know how maintenance slows everything down on Earth. Imagine that on the moon where repairs are very hard. SpaceX solved that with modular automation. Each unit functions independently and links with lasers. That is how they multiply the output so fast. Other companies are limited by payload and fuel costs. Boeing tried similar concepts, but they maxed out early. Even the NASA Artemis program cannot match these numbers. Gravity and atmosphere on Earth make everything expensive. On the moon, gravity is only 1/6. Less gravity means more mass can be launched easily. The mass driver hurls satellites without wasting fuel. Musk mentioned 1 megaton of hardware per year. The moon factories multiply that over time. That is the competitive scoreboard. Starship delivers gigawatts, but mass drivers deliver terawatts. It compounds every year. Engineers were 30 seconds from disaster during one test. They still got the hardware into orbit safely. By December 2025, posts showed the production. Solar cells and chips are made and integrated in each unit is a node in a planetary grid. This multiplies power without human labor. You know how expensive human oversight is. This eliminates almost all of it. One satellite gives 100 kilowatts. 1 megaton gives 100 gigawatts, but moon launches give over 100 terawatts. That is enough to run artificial intelligence at a massive scale. Each solar array can power hundreds of homes. Each mass driver launch is like a railgun shot. One slight miscalculation and you miss orbit. One engineer adjusted the rail settings in real time. He got it exactly right. Previous attempts failed because Earth launches were too slow. You can see examples of this in history. Boeing and China tried but hit limits. Starlink worked for communication but not for big computing. China is at a fifth of what SpaceX achieves. Pattern recognition shows a very clear edge. Moon production is orders of magnitude larger. factories are built from soil using three-dimensional printing. They are fully automated and use nuclear power. Each unit has solar panels and thermal radiators. Mass drivers hurl them into stable orbits. This keeps them in the sun for constant energy. Artificial intelligence runs on electricity, so sun is critical. SpaceX solved this with coordination algorithms. The satellites are laser-linked for speed. They share tasks instantly with no radio lag. It is like a global supercomputer floating in orbit. Earth-based farms cannot match this scale. Every terawatt added compounds the previous gains. This gives Musk and SpaceX a huge future position. They are setting up for decades of growth. Annual additions of compute will soon pass Earth capacity. Boeing and NASA might catch up, but only slowly. Lunar infrastructure takes a long time to build. Starship launches remain limited by Earth physics, while SpaceX expands. The rest are counting budgets. Those who mastered the system reaped the rewards. Technical mastery shows in every single number. Musk's insistence on mass drivers was debated. Some engineers wanted conventional rockets. Rockets maxed out at 500 gigawatts. Mass drivers promised 100 terawatts. That is 200 times more power. The board trusted physics over tradition. By late 2025, the first driver was working. That decision led to the scale increase. Each launch afterward exceeded the expectations. Flight planners report over 95% accuracy. Early tests were 30 seconds from disaster. Adjustments were made in real time. This competence reassures investors and engineers. Future projections are mind-bending to consider. Compute power will soon manage planetary scale tasks. Climate simulations and global logistics will be fast. The moon becomes a factory for the future. Mars and other colonies will benefit directly. No other entity can match this trajectory. Mass drivers are tuned with electromagnetic force. The payload is a package of hardware. Each rail segment has a specific output. Timing must be perfect to reach orbit. Small errors send billions of dollars off course. Engineers found the precise settings through simulations. That mastery translates into real-world capability. Patterns show a timeline of rapid growth. Small units in 2024 led to nodes in 2025. Fully automated lines were ready by 2026. That is acceleration. Financial analysis confirms the efficiency. A conventional launch costs $90 million. Mass drivers reduce that to a tiny fraction. Teams worked for months on the software. Engineers stayed in shifts to monitor the work. Mistakes could have been catastrophic. One misalignment could have destroyed the payload. They corrected it with split-second precision. This is competence validated through results. Lessons were recorded to ensure future success. Laser-linked satellites allow for distributed processing. That was never done before at this scale. Usually satellites worked alone. SpaceX connected them to multiply efficiency. This is a system-level innovation. Nodes handle redundancy automatically. If one unit fails, others take over. That dominance is baked into the design. The grid supports terawatt-level computation. Every step forward compounds the last one. Victory validation comes from the numbers. No Earth farm can match this scale. Lunar production redefines technology leadership. Companies on Earth will struggle to keep up. Strategic positioning guarantees dominance for SpaceX. Competitors cannot match the speed or volume. Over 6 months, the production increased by 30%. Latency dropped to microseconds. Success exceeded 98%. These wins reinforce the magician archetype. Impossible things become reality through skill. By the end of 2026, the moon is a hub. Each unit contributes to a massive grid. The mechanics and decisions validate the approach. Victory metrics are very clear. Starship is limited, but mass drivers are massive. Competitors can only watch the gap widen. Mastery over the moon railgun infrastructure is the key. The next frontier is not about rockets. It is about who controls the rails. SpaceX positioned itself far ahead of any competitor. The path forward is bright and grounded in science. The moon is the engine of the future. It powers artificial intelligence across the solar system. The engineers transformed impossible forces into a repeatable system. They solved near misses and proved reliability. Future projections show daily multi-ton launches. Mastery turns the impossible into the achievable. You see where this is going? The scoreboard favors SpaceX, and the future is being built right now. SpaceX did not just create satellites. They created a new era of computation and logistics. Your world is about to feel the impact of this achievement. SpaceX leading the way means a multi-planetary presence is coming soon. The future is not just imagined. It is being built one starship and one railgun shot at a time.